Hello friends, today I will discuss about differential relay characteristics of Micom P63X, that is P631, P632, P633 and P634. Characteristics of all the P63X relays are same. Difference is only on binary input and output contact. The characteristics of Micom P63X has been shown in this diagram. The differential current in power unit quantity has been shown in the y-axis, and bias current in power unit quantity has been shown in x-axis. Here differential current is nothing but the vector sum of the primary and secondary current, which is converted in percentage of full load quantity. That is, I1 is the percentage of the full load current in the HV side, and I2 is the percentage of the full load current in the LV side. All the quantities are converted in per unit quantity. ID is the I1 plus I2, that is the vector sum of I1 plus I2, and the bias current is the average of the I1 plus I2, that is scalar sum of I1 plus I2 by 2. So these are the differential current and the bias current for Micom P63X, and the characteristics has been shown. Here only for the differential, initial shifting is given, that is I differential greater than, and then there exists two slope. One is K1 and another is defined, that is higher slope, that is K2. And the K2 slope is starting point, that is, or the boundary region which defines or differentiate between K1 and K2 slope, which is I bias. And again there exists another setting which is I differential high set. And if the lower portion is the restraining region or the blocking region, and upper portion are the operating region. So for the first section or first region, the blocking region has been shown. If the differential current is greater than I differential greater than, that is the initial setting for differential current, then relay will send a trip signal to the circuit breaker. And boundary for which up to this condition shall be satisfied is I bias is equal to 0.5 into I differential greater than. If the initial setting is 0.2, then I bias is equal to 0.5 into 0.2 is equal to 0.1. And for the second section or for the second region, the blocking region has been shown in the red color, and beyond the blocking region, I differential current must be greater than K1 into I bias plus I differential greater than into 1 minus 0.5 into K1. I bias is the bias current in this region, and the boundary for which this condition shall be satisfied is IR in per unit quantity. Now the characteristics of Micom P63X is slightly different from that of the Micom P64X relay. The initial slope in Micom 64X relay meets in the origin, but in case of Micom P63X, if we draw the initial slope towards the x-axis, there will be a certain value. So if we draw the straight line from initial slope, that is K1, it will meet the x-axis or differential axis at point P. So we can get the value of OP from the equation, that is I differential equal to K1 into I bias plus I differential greater than into 1 minus 0.5 K1. So at point P, the value of the bias current is equal to 0, that is I bias equal to 0. So we'll get the I differential is equal to I differential greater than into 1 minus 0.5 into K1. So if the value of the K1 is 30%, that is initial slope is 30%, and I differential greater than is equal to 0.2 per unit, then we will get the value of OP is equal to, or I differential at point P equal to 0.2 into 1 minus 0.5 into 0.3, which comes as 0.17 per unit. Now for the third section, the restraining region has been shown in the red color. The third section, the boundary for the bias current is IR, and beyond this bias current, the higher slope is given in order to prevent the relay to send a trip signal due to CT saturation. So we know the value of the OP. OP is equal to I differential greater than into 1 minus 0.5 K1, and from the triangle OP, from the triangle PXY, we will get the value of the XY as equal to IR into K1. So we can calculate the value of the I differential for second slope region that must be satisfied in order to relay to send a trip signal. So I differential must be greater than I differential greater than into 1 minus 0.5 K1, that is the value of the OP, and plus IR into K1, that is the value of the XY, and then plus I bias minus IR into K2. So this condition must be satisfied for differential current for value of the bias current which is greater than IR, and this must be satisfied up to the value of the I differential current IDHS. If the IDHS is greater than if the differential current is greater than IDHS, then it will not depend on the value of the bias current. So this is the region for the third slope. So in this diagram we will calculate the value of the matching factor. So in case of numerical relay, if we put the MVA capacity of the transformer and HV side winding voltage and LV side winding voltage and HV side CT ratio and LV side CT ratio, the relay will automatically calculate the matching factor for LV side and HV side respectively. So in case of in this diagram, the MVA capacity of the transformer is 36 MVA and HV side voltage is 52.5 kV and LV side voltage is 10.5 kV, and vector group is DY7. Winding A is the delta side and winding B is the star side, and HV side CT ratio is 400/1 and LV side CT ratio is 2000/1. So HV side full load current is 36 divided by root 3 into 52.5, which comes as 396 ampere, and LV side full load current comes as 36 divided by root 3 into 10.5, which comes as 1979 ampere. So in the HV side, the matching factor K amplitude HV is equal to CT ratio divided by HV side full load current, that is 400 divided by 396, which comes as 1.01. Again for LV side, K amplitude LV side is equal to LV side CT ratio divided by LV side full load current, which comes as 1979 is equal to 1.01. So this value is automatically calculated based on the input given to the relay. Again for angle matching, relay will automatically calculate based on the vector group given to the relay. So friends, if you like my video, then do subscribe my channel and press bell button for notification of videos to be uploaded in future. Thank you for watching.